Okay, so today we're going to look at a different kind of graph. Okay, we studied linear functions yesterday. Today we're going to look at quadratic functions. Okay, we're also going to take a look at how we can transform them, okay, how we can shift them either up and down or left and right, okay, things like that. So first of all, a quadratic function, this is one way you can write it. Probably seen this form a lot when you do factoring in Algebra 1. Ax squared plus bx plus c. What's important is that a, b, and c are elements of the real numbers. That's what that means. A, b, and c have to be real numbers. They can't be imaginary. And a can't be 0. Because if you make a 0, what's 0 times anything? 0. Now you just wipe this term out. You don't have a quadratic anymore. Now you have a linear function. Bx plus c. Right, so that's the form you usually see a quadratic function written in. Right, I'm going to graph y equals x squared. And we should already know what shape that's going to be. What does that look like? Yep. Yep, it's a parabola. Right, so if you just graph it, it goes right through the origin, it opens upward, and it takes one turn. Okay? Okay, now what I'm going to do is I'm going to graph, instead of plugging in x, I'm going to plug in a negative x, okay, with parentheses around it, and square it. And let's see what that looks like. So what's the difference between f of x and f of negative x? About Zach?
Nothing.
Nothing. They're the same graph. All right? So what that means, if you graph something and it comes out the same, okay, like that, when you plug a negative in for x, that means it's symmetrical over the y-axis. Okay, that's what that means. Here's a graph where it would look a little different. Here's x cubed. Okay, if I graph that, it looks like that. Now, if I plug in a negative, it's not going to look the same. Okay? So let's try negative x cubed. What you're going to see is a mirror image over the y-axis. Okay? The reason you didn't see that with a parabola is because a parabola already is a mirror image over the y-axis. So when you make it another mirror image, it stays the same. Okay? But that's what plugging in a negative for x does. It reflects it over the y-axis. Okay. Parabolas contain a low point, but it could also be a high point, depending on if you flip the graph not over the not over the y-axis, but if you flip it over the x, you could change your vertex from being a low point to being a high point if you flip it. Okay, so I want to take a look at graphing a few of these. I'm going to graph x squared, 1/3 x squared, and 2x squared, and see if we can tell what's the effect by changing the coefficient of x. Does anybody have a guess what changing the coefficient of x is going to do? Yeah?
It's going to change how wide the parabola is.
Okay, so it might change how wide or narrow it is. Let's take a look. So we've got y equals x squared. And let's do 1/3 x squared at the same time. There's 1/3 x squared. Okay, and I'm doing everything in a standard window. Okay, so you're going to see this time when it graphs it in red, your graph looks there's two ways to look at it. It looks like it's stretched out more horizontally, or imagine taking that blue graph and pushing down on it, compressing it vertically. Okay, it would kind of squish out sideways. What do you think is going to happen if I change this 1/3 to a 2? Yeah.
It's going to narrow.
Yeah. Instead of stretching it out sideways, or think of it as squishing it vertically, it's going to stretch it vertically. Okay, so now it's going to look more narrow. Okay, it's going to be completely inside that blue curve, except for the vertex, which is on the curve. Okay, so changing A has an effect of how wide or narrow the parabola is. So I want to think of it vertically. All right, so if you plug in a number bigger than 1, it stretches the graph vertically. If you plug in a number between 0 and 1, like 1/3 or 1/2, it compresses the graph vertically, or it shrinks the graph vertically. Okay, I'm going to do the same graphs again, except now instead of just putting a different number in front, I'm going to add one more thing. I'm going to put a negative. Does anybody have a guess what putting a negative is going to do? We kind of explored this a little bit earlier, but this is a little different this time. Well, what did putting a negative in for x do before? Yeah. Yeah, if you change all your x's to negative x's in parentheses, it does a mirror image over the y. Well, we're not putting a negative in for the x. We're putting a negative in front of the whole thing. So it's not going to mirror it over the y, but this time it's going to mirror it, yeah? Yeah, it's going to create a mirror image over the x-axis. And just, I'll just show you that with x squared. Again, we're not plugging in a negative for x. We're just sticking a negative in front of the whole thing. Okay, and that causes the parabola to now open downward. So depending on where you put the negative, you can change what kind of reflection you get. All right, so can somebody tell me how this graph comes from this graph? There's actually two things happening. The 5 is going to do something, and then the negative is going to do something. Okay, let's start with the 5. What is the 5 going to do to the graph of x squared? Yeah?
It's going to stretch the graph
In which way?
vertically.
Yeah? So that we call that a vertical stretch. And it's by a factor of 5. Okay, so the first transformation is a vertical stretch, and then we have to say how much. By a factor of 5. Okay, so we just explained what the 5 is going to do, and somebody explained to me, what does the negative in front cause to happen? Yeah, Josh?
It causes it to mirror over the x-axis.
Yeah, this is going to cause a flip or a mirror image, or you could say a reflection over the, which axis? Right, this is going to reflect over the x-axis when you put the negative in front. So reflect over x-axis. Now in this case, the order that you do these transformations in doesn't matter, but in general it does. Think of PEMDAS. Okay, it makes a difference the order you do calculations in. So we're going to discuss an order, and we're going to have an order that I show you eventually. So you'll always remember what order to list these in. Okay? But you don't have to be too concerned with that yet. All right, any guesses on how putting a -3 on the end or a +2 is going to affect the graph. What do you think this is going to do? Yeah?
It's going to change where the vertex hits the y-axis.
Okay, in which way? How is it?
Well, if you put a -3 on the end, it's going to bring it down
Okay, so if it's a negative, use the word down. Don't use a negative when you're talking about the shift. Okay, so any questions on a vertical shift? All right. Another transformation. I'm going to add or subtract a number, but now this time it's going to be inside the parentheses. It's going to be part of the squaring function. Any guess what direction this is going to move things in? Yep.
If it's positive, it's going to go right. If it's negative, it's going to go left.
All right, so you're thinking horizontal transformations? Yep, I like the idea of it being horizontal. Let's try it and see. So you're thinking that if I type in, let's do the first one, x minus 3 squared, you're thinking that should move left. All right. So you're thinking somewhere over there. Well, it moves right. All right, so that one's a little tricky, okay? And we'll see that a lot of times all year long, okay? Whenever you have a horizontal shift, it's really the opposite of what you would think. Okay, so if you have a minus, it'll shift it right. If you have a plus, it would shift it left. Okay, and that's the way it works. Again, a horizontal shift, that's a rigid motion transformation. It doesn't distort anything, it just moves it. Okay, so if h is a value that's greater than 0, okay, you're shifting, you know what, let's think of it, well, there's two ways you can think about it. You can think about your problem like this. Let's say like x minus 3. And just remember that it always does the opposite of what you would think. Or you can think about it like that. Okay, always changing it to a plus sign. Okay, what I would do is I would think about it, I like thinking about it this way. Okay, the first way. I just look at it and say, if I see a minus 3, that's going to shift it the opposite way that minus goes. If I see a plus 3, that's going to shift it the opposite way of plus. It goes to the left. Okay, so I think to simplify it, I'm just going to write it that way. Okay, so it's the opposite of what you would think. And I'll write it right here. So minus 3, that's going to shift right 3. Plus 2 is going to shift left 2. That's what I mean by opposite. And of course, anytime we shift, we're moving that vertex. Okay, so if this is your graph, okay, the only two things there that really affect where the vertex is going to be are shifting left and right and shifting up and down. Those are the only transformations that actually move the vertex. Okay, so if you have an equation in this form, your vertex would be at h, comma, k. And it has to be exactly in this form. If this is a plus sign, like x plus something, we have to be very careful about the sign with h. Okay, and we'll try one of those. Okay, and of course, if you shift the vertex left or right, you're also shifting the line of symmetry. Okay, so if this is my parabola, what value here, h or k, has no effect on the line of symmetry? Yep. Yeah, k is a vertical shift. So if I have a parabola, which I'll just trace one right on top, and I shift it up, that does nothing to the line of symmetry. It's still the same line of symmetry. Okay, so k has no effect on the line of symmetry for a parabola. It's h, because h is your left and right movement. That changes the line of symmetry. All right, so that's why when we shift the parabola, we say this is the equation of the line of symmetry. X equals h. All right, so let's see if we can find the vertex and line of symmetry for this equation. Y equals x plus 2 squared minus 3. Now, be careful, because I said it had to be written as x minus h. This is x plus h. So if you want to think of it as a minus, what could you write inside the parentheses there? X minus what number? Right. You could think of it as x minus negative 2. Okay. Whatever number comes after the minus sign, that's h. Okay? So what number comes after the minus sign here? Negative 2. That's h. Okay, so just be careful with the sign. It's the number after the minus sign. All right, and what about the k value for my vertex? What is it? Yeah, negative 3. So in this case, the vertex has been shifted left 2, down 3. Okay, remember, opposite of what you would think. You see plus, you might want to think it goes towards the plus, the right side, but it doesn't. It goes left 2. Okay, and what's my line of symmetry? X equals what number? About Andrew?
Negative 2.
Yeah, x equals negative 2. Because I shifted this entire graph left 2 units. So the vertical line of symmetry also goes left 2 units. Okay, any questions on that? All right, let's try one where we list off the transformations. First of all, can somebody just tell me how many transformations do you need to do to change this into that? How many things are going to happen? About Francisco? Okay, that's 1. And what's another transformation? The 5. So how many total? 2 transformations to change this into that. Okay, and the order here matters. Okay, think of PEMDAS. What would you do first here? If you were doing PEMDAS, would you multiply something by 5 after you squared it, or would you add 4 first? You'd multiply by 5. So that's the first transformation we're going to do. Okay, what does putting a number in front of the x squared do? Yep.
That stretches it vertically.
Yep, so it's a vertical stretch. You just have to tell me by how much. Yes. Okay, make sure you tell me the direction it stretches and how much. Vertical stretch by a factor of 5. What about that plus 4? What does adding a plus 4 on the end do? About Josh?
Plus 4?
Yeah.
That shifts it up.
Right. When it's outside the argument that's squaring, that shifts up and down. So then shift up but then tell me how much. If you just said shift up, I'd only give you half credit for that part. It's true, it does go up, but you didn't say how much. Any questions on that? All right. Let's try this one. Okay, so they want me to describe the transformations again and find the line of symmetry. Remember, what's the only thing that affects line of symmetry? What kind of transformations? Josh?
Horizontal shift.
Horizontal shift. Vertical shift, stretching, flipping, that kind of stuff doesn't affect it. At least flipping vertically, okay, over the y-axis, x-axis. Okay, how many transformations are happening here? Any thoughts? How about Pacey? Any thoughts?
3.
Okay, you could write it as 3. I'm going to argue it's 4, just because we're going to break one of those transformations down into 2, okay, having to do with a flip and a stretch. Okay, so we'll break it down. So if you were doing order of operations, where would you start here? About Amanda? Nope, not yet. That's not. It's not going to be our last one, but it's not going to be the first one we start with, just because we have some symbols here. Grayson? Yeah, you'd start in those parentheses. Okay, so you're going to start with this -1. What's the -1 going to do?
Shift
Yeah,
it to the right.
okay. It's going to shift it to the right. How many units?
1 unit.
Yes. Shift right 1 unit. Now we're going to go outside those parentheses. Okay, what's the very next thing right on the outside of the parentheses? Hello, Zach?
The -3.
Yep, and the negative and the 3 are 2 separate things. Okay, which one you write first really doesn't matter. But I'm going to start with what's closer to the parentheses and deal with the 3. Can you tell me what that's going to do?
It's gonna.
Okay, that's a vertical stretch. Okay, and how much is it going to stretch by? How about Ayla?
Factor 3.
Yeah, vertical stretch by a factor of 3. All right. What's the next thing that's going to happen? We've got a negative, but it's on the outside. Okay, it's not with the x in parentheses. So what did we say that does?
Reflection of the x-axis.
Yep, that's a vertical reflection. You can think of all your vertical stuff as together, or if you flip vertically, it's over the x-axis. So reflect over x-axis. Or you could say a vertical reflection over the x-axis, same thing. And the last thing is a +4 at the end. That shifts up 4. It's not necessary to say a vertical shift up 4. You can if you want, but if you say up, I know that's vertical. So you have to say up and 4 units at a minimum. Okay. And what's the last thing they want? The line of symmetry. Okay. Line of symmetry is always a vertical line for a parabola. And how about, Molly, the equation of a vertical line starts out how? Y equals is when it's horizontal.
I wrote y equals x for vertical shift. That's why I don't know why.
Anyone help her out? What's, yep, quick.
X equals.
X equals. Okay, so anytime we have axis. So reflect over x-axis. Or you could say a vertical reflection over the x-axis, same thing. And the last thing is a plus 4 at the end. That shifts up 4. It's not necessary to say a vertical shift up 4. You can if you want, but if you say up, I know that's vertical. So you have to say up in 4 units at a minimum. Okay. And what's the last thing they want? The line of symmetry. Okay. Line of symmetry is always a vertical line for a parabola. And how about, Molly, the equation of a vertical line starts out how? Y equals is when it's horizontal.
I wrote y equals x for vertical shift squared on y.
Anyone help her out? What's, yep, quick.
X equals?
X equals. Okay, so anytime we have a line of symmetry, it's always the form x equals and then a number. And can you tell me, Quinn, what's it going to be here? X equals,
-1.
careful, which way did we shift it?
Oh, is it positive 1?
Yeah, remember, it's always the number after the minus sign that tells you your h value, okay? So since we shifted right 1 unit, the line of symmetry also went right 1 unit. Okay. Questions on that? Just takes a little getting used to with the transformations, but once we learn them, transformations are actually the same for every function we're going to study all year. Whether it's a sine or a cosine function or square roots, logarithm, exact same rules every time. Okay, so that's the order that you want to do your transformations in. You always start inside your parentheses with your horizontal shifts. Okay, we are not doing horizontal reflections in this section. But if you were, they would be the next thing we would look at. Okay, but for this section, just worry about your horizontal shifts. Okay, then go outside the parentheses and start looking, is there a number in front? If it's bigger than 1, it's going to be a stretch. Between 0 and 1, you're going to get a compression or a shrink. Next, is there a negative on that number outside the parentheses? If there is, that'll cause a reflection over the x-axis, a vertical reflection. Technically, you could reverse the order of steps 2 and 3, and the answer is still correct. But just stick with this order, and it'll make things simpler. And then the last thing is your vertical shifts. Okay, that's always the very, very last thing you look at. All right, so far all the examples we've looked at have been written in a very nice way where you can directly look at it and you can see how much it's been shifted left or right, how much it's been stretched, and how much it's been shifted up or down. Okay, they haven't been written in that form that I showed you at the very beginning, ax squared plus bx plus c. Okay, that's what we're going to take a look at next. Okay, when we don't have something in standard form, how do we deal with it? All right, so if you've got something in this form, it's going to be kind of hard to tell the transformations. Okay, looking at 3x squared plus 12x minus 18, I don't know how much it's been shifted left, right, up, down, stretched. I can't tell. I need to rewrite it. And the way we rewrite it is completing the square. Okay, so I'll go through an example completing the square rather than go through all the verbal steps of how to do it. We'll just do an actual example. Okay, and the big thing when you complete the square, just keep the equation balanced. Remember, whatever you do to one side, make sure you do to the other. Right, so this is the same kind of question they've asked me before. Just describe the transformations. I just can't do it right away. All right, so first step when you're completing the square is to make sure that we put the constant on the other side. That's the first step. So I basically just added 18 and moved it to the other side. Any questions on that stuff? Okay, next step. To complete the square, you don't want a 3 here. Okay, you want a 1 there. So does anybody remember the term when you take something out, begins with an F? Yep, we're going to factor out a 3. Remember that 18's on the other side, so that's not affected. So move constant, other side, so that's not affected. So move constant to other side. I factored out a 3, so I could get x squared just with a coefficient of 1. Okay, now the next thing I'm going to do is complete the square. To complete the square, you have to add a number to both sides. It has to do with this 4. Does anybody remember what you do with this 4? It's actually 2 things you do with it to figure out the number that completes the square. Remember that? Okay, you take half of 4, you get 2. That's the first step. And anybody know what you do after you take half of 4? Think about the name of this process. That has something to do with it. Yeah? You square it. Okay. So in this case, not much interesting happens. Take half of 4, you get 2. Square it, you get 4. Okay? So the way you do this, take half of the b term. Remember, ax squared plus bx plus c. Okay, so take half of the b term and square it. That's how you get that. Now, what did I just add to the left-hand side? 12. A lot of people miss that, right? I didn't add 4. I have this 3 on the outside, so I really added 12 to the left. So to keep everything balanced, I need to add 12 to the right. Sometimes you don't have to factor out a number. It's already nice, and x squared doesn't have anything in front of it. If that's the case, then you wouldn't have to worry about what we just did there. Okay? Whatever you put here is what you would put on the other side. But in this case, you really did add 12. And now if we've done everything nicely, okay, this should factor very nice. What does x squared plus 4x plus 4 factor into? Oh, Amanda? X plus 2, x plus 2. Or how else could I write that? Right, that's the whole point of completing the square. It's always going to factor into something times itself. X plus 2, x plus 2. And now I can just about see all my transformations. All right, so I'm just going to finish it up by rewriting it a little nicer. It's 3x plus 2 squared minus 30 equals y. Now you could graph what's in the box and graph the original problem, and they should be exactly the same thing. All right, so what's the plus 2 doing? It's going to shift the graph which way? Yep. Yep, it's going to shift left how many? 2. Shift left 2 units. I've got a 3 on the outside. What's that going to do? Tom?
It's going to stretch it.
Which direction and how much?
Going it narrower by a factor of 3.
Okay, I like the factor of 3. Just looking for one word in there.
Stretch.
And one word before that one. Vertical. That's a vertical stretch. But that's good. Vertical stretch by a factor of 3. And the last thing, what's that minus 30 going to do? About, Molly?
Well, wait, is that when it goes like up and down?
Yep.
So, like the
That's going to go down, yeah. It's going to shift down 30 units. All right, now, if they didn't want to know the transformations, okay, the way we just did them, let's say all they wanted to know is, what's the vertex of this graph? Well, I know the vertex now is -2, -30. It went from the origin, it went left 2, and it went down 30. But if that's all they wanted to know, is just the vertex, I actually have a formula. I can figure out the vertex without completing the square. Okay, so we don't use these two formulas a lot, but they're there if you want to try them. You have to know your A, B, and C values. And it gives you a way to find the vertex, -b over 2a, comma, c minus b squared over 4a. Might see some elements of quadratic formula in there, kind of. But you can technically find the vertex and the line of symmetry without completing the square. If they want to know the transformations, then it's really better to do it the way I showed you. Complete the square. Okay, so this is a shortcut. If they don't really want to know the transformations, they just want those two things. And the last thing, we talked a little bit about this on a calculator, is finding where something crosses the x-axis. Okay, that's called the zeros of a function. Or sometimes it's also called the roots of a function. What value do you plug in for x that causes it, the y value, to be 0? Cross the x-axis. Now with quadratics, you've got 3 cases. It can cross the x-axis twice. It can just come down, touch the axis, and go away from it. Or it might not cross the x-axis at all. Well, if all they want to know is, how many times does this parabola cross the x-axis? All you have to do is take your quadratic equation and figure out this value. Find out what b squared minus 4ac is. If it comes out less than 0, the graph would never cross the x-axis. If it comes out equal to 0, it would cross it 1 time. And if it comes out more than 0, it would cross it 2 times. Hopefully you recognize that from the quadratic formula. It's the thing that's under the square root. And hopefully it also makes sense that if the thing under the square root was less than 0, it would be negative. The square root of a negative is imaginary. It would never cross the x-axis. Okay, so that's a quick little shortcut to figure out how many times does a parabola cross the x-axis. Questions on that? Okay, so the last example in this section, I'm gonna hold off on that. I'll give you one like it in the homework to try. And if you get stuck on it, we'll do it together tomorrow. So don't worry too much if you get stuck on it. Okay, homework tonight just on one page. We'll also, tomorrow, we'll just be doing one section as well. Okay, it's on page 56. And it's just a bunch of different problems. Okay, so it's 1, 2, 7, 8, 10, 11, 16, 18, 21, 22, 28, 33, 40, 41, 44, and 60. I think it's like 16 problems or so. Might be 17 problems. Okay, so we'll take a look at that first thing tomorrow.